This is Michelle Casbon. She's an engineer at Google on the Kubeflow team.
And this is John Bohannon. He's the Director of Science at Primer, an AI startup.
My team at Primer built a machine learning system that reads millions of news articles and tells you what it learns.
And I worked with them to deploy this system with Kubeflow to make it portable and scalable.
The goal is to create a machine to help humans learn about the world and overcome their biases. Humans are biased.
Consider this riddle.
A boy and his father are in a car crash. The father is killed instantly. The boy is rushed to the hospital and prepped for surgery with one of the best doctors in the country. The doctor arrives, sees the boy on the table, and says, "I can't operate on this patient. He's my son."
Who's the doctor?
It's a paradox, right? Father's dead, so...
It's the boy's mother.
For those playing at home, don't feel bad. 85% of people are stumped by this question. It even worked on Michelle when she first heard it.
Bias is powerful. All humans have it, and we all have to work against it constantly.
Every time you meet someone, you can't help but make assumptions.
But you're probably biased.
Wait, that one's actually mine.
And that one's mine. Oh.
You're totally biased.
Well, any system built on human decisions will inherit human bias.
Consider Wikipedia. It has grown into the world's most important general-purpose information resource, but there's no one in charge. Information is added to Wikipedia day after day by millions of volunteers. It just boggles the mind that such a thing can exist and that it actually works. Wikipedia aims to be the summary of all human knowledge, but it has biases, just like the humans who create it.
If you think about all the new things we learn about the world each day, keeping Wikipedia up to date seems impossible. It's not just that important information is missing from most articles, but it's that many important articles haven't been written at all.
Which shouldn't be that surprising, right?
Well, so there are about 5 million Wikipedia articles.
In English alone, yep.
And there are some thousands of news articles published every day.
Hundreds of thousands, just in English.
So you just have to read all of it. You find the important information that's in one set and doesn't exist in the other. Okay, yeah, that's hard.
Machine learning to the rescue. I decided to start by focusing on people. We want a system that just reads all the news every day and learns new information about everyone. Not only people described in Wikipedia, but anyone described in the news. And if there's enough significant information about someone in the news who's missing from Wikipedia, the system should just write you the first draft of the article. The goal is to make it as easy as possible for the human editors of Wikipedia to do their job. And the first step is to shine a really bright light so we can see where our bias is.
For example?
Well, for example, only about 15% of Wikipedia's biographical articles are about women, and that gender gap is especially bad for scientists. If you never hear about all the amazing women of science and engineering, then it reinforces your bias about those professions.
Exactly. And that's why I wanted to work with Primer on this in the first place.
Right, and here we are just a few weeks later, and we're actually catching up on where we are with deployment. So, where we left off, we had this really cool ML system with some really classic ML deployment problems.
Kubeflow to the rescue!
Our first problem was scaling. So the computing load is all over the map on this one. On any given day, we're like processing hundreds of thousands of documents, news articles, scientific papers, and we're updating information about people in our knowledge base. But we also have users who might want to add thousands of new people all at once. And that kicks off a backfill of information about those people from millions of historical documents.
This turned out to be easy to solve because your team had already set up a Kubernetes cluster. Now, Kubeflow is built on Kubernetes because scalability is baked into the platform. The application backend was built on top of Postgres, which was a straightforward migration into Cloud SQL. Once the data was migrated, I transplanted the full app into Kubernetes engine. I started with a single node cluster and enabled auto provisioning, which scales the size of the cluster up and down based on resource requests. So now we can deal with unpredictable and bursty computing loads like yours.
Okay, but on top of the scaling problem, I've also got a complexity problem. So our data pipeline has a bunch of spaghetti junctions, and not only do we have thousands of models to load at inference time, but we have to update those models as new information comes in. So at training, it adds up to like millions of model features getting updated every day.
I noticed that. Luckily, this is exactly what Kubeflow is designed for, composability. The platform provides patterns for reusing common ML tasks, like updating models incrementally in the background. I started by carving out pieces of the app. For example, model training was refactored into a separate service that uses Kubeflow operators. The monolith is now separated into smaller, distinct pieces. Now it's a pipeline with 3 separate steps: train, serve, and web app.
Oh, that sounds much nicer. Okay, so how's it looking so far?
Well, the refactoring immediately reduced the training runtime, so that translates directly to cost savings. And now you don't have to run huge nodes all the time because GKE takes care of the scaling for you. Well, the other win is the decrease in code complexity. That translates to less maintenance overhead, less time searching for the source of bugs, less time on-ramping new engineers, and adding new features.
Okay, but that creates a new problem.
What haven't I thought of?
So, now we have all this saved time. What am I going to do with all my time?
You could create some Wikipedia articles about women of science.
Good call. Oh, and what about the last thing on my wish list about vendor lock-in? We don't want our system tied to one cloud infrastructure. We want it to be able to deploy anywhere, even on-prem. Oh, and bonus points if the solution is free and open source.
Check and check. As long as you're running standard open source Kubernetes, you can run Kubeflow.
Wait, Kubeflow is open source?
Yep.
What?
Thanks for listening. I hope that hearing about this project lowers the bar for trying it yourself. The Kubeflow community has some great resources for getting started, which you can find at kubeflow.org.
And hey, got a few minutes of free time? I've already used this machine learning system to identify thousands of notable women of science who are missing from Wikipedia. You can make a difference right now. Just follow this link and see what the machine has discovered for you. Go fill in a gap in the world's knowledge.